Hi everyone, my name is Thomas Kim. Today is February 11th, 2021. This is my 76th episode about the programming language C++ 20 standard. In this episode, I will discuss Decltype ORO L-value reference, ORO R-value reference. This ORO is more like forwarding reference, ownership, and R-value reference. Without understanding ownership, you can never say you truly understand R-value reference. R-value reference is reference, but it owns the object it references to. So, R-value reference is reference, but it owns the lifetime of the object it references to. Please don't forget this. If you forget this, your understanding of R-value reference slips away from your fingers. Without further ado, let's get started. I assume you have watched my previous two episodes, especially episode 74, episode 75. If you haven't watched my previous episode, please watch this video. Please don't miss episode 75. Now scroll down, show more. In the download source code section, please double click this link to download the source code from our previous episode. Show in folder, unzip it, right click, rename 76, ownership. Copy the folder path, copy, paste it in your working folder. Start Visual Studio Code, open your working folder. From episode 76, double click this file, Ctrl B. Now, in the command prompt, dir cd 076 ownership clang std c++ 17 decl oro.cpp ltbb o c.exe. Hit enter. clsc. Please understand that we created this program in our previous episode. We are calling from this function sum by passing a, b, c 10 integers. In the function sum, we create an instance r. The address of r is 854. The value of r is copied to an internal place by the compiler. The compiler copies the value to t. So t. Finally, the address of x is 9dc. So this is equivalent to a plus b plus c plus j, or 1 plus 2 plus 10. If we don't use Decltype ORO move semantic, now let's see what it happens. Now I will fix like this. Return type is now ORO. We build again CLS C. Now T address is all the way different. Every each step in this computation, a new value is created, temporary new value. I will turn it back. like this. I turned it back. Now we build CLSC. Now temporary R is created only once. It is possible because we moved and we used Decltype auto. In this block of code, we filtered out T is rvalue reference. Then why do we need std move here? Now let's double check. Stream, the type of T, talk, play, fun, get type category, T, and there. Copy once, paste, copy this, paste it here. I will arrange like this. Then copy this, paste it here. We have to use getType category because T is instance. std move T is still instance. Now we build again. CLSC. The type of T is integer rvalue reference. std move T is integer rvalue reference. They are exactly the same type. So I will disable this. Then T. Now we build again CLS using clang compiler. Now scroll up. The error message says rvalue reference to type int cannot bind to lvalue of type int. Copy this, paste it here. rvalue reference to type int. Please notice this is not rvalue to type int. It is rvalue reference. Cannot bind to lvalue of type int. Please notice this is not lvalue reference. This is lvalue. T is named. Anything that is named is lvalue. lvalue has ownership. lvalue has ownership. Whereas lvalue reference does not have ownership. rvalue does not have ownership, but rvalue reference has ownership. Don't get confused. rvalue with rvalue reference, lvalue with lvalue reference. Now here I typecast int rvalue reference. T is already rvalue reference, but still we typecast to rvalue reference. Once again, T is already rvalue reference, but still we typecast rvalue reference to rvalue reference. Don't get confused. The type of T is rvalue reference. It is lvalue. Once named, it is lvalue. All misfortune arises out of confusing lvalue with lvalue reference, rvalue with rvalue reference. But you can understand it very simply if you understand the ownership. Now we build once again hit enter. CLSC, it built successfully. Now you see the type of T is rvalue reference. This is not rvalue, this is rvalue reference. std move T is still rvalue reference. Then why do we need this? I will delete it. Build again. It does not work. I will put back. Now it builds successfully. Why? That is the contract. T is named by the programmer. Once named, anything that is named by the programmer is LValue. So even though T's type is rvalue reference, rvalue reference has ownership. Once T goes off this function, T does not exist. We are using recursion. So once T returns, here in this part, T does not exist because T is LValue and T is rvalue reference. LValue has ownership. rvalue reference has ownership. So once this function sum returns, the object that T references to is rvalue. rvalue does not have ownership, but T is rvalue reference. The ownership is destroyed because we are using recursion here. Once this function is returned, ownership is destroyed. T is rvalue reference. Its ownership is destroyed. Using this typecast, we are informing C++ compiler. Now we are relinquish our ownership. We are transferring our ownership, transferring the ownership of T. So just proceed. It is a contract in C++ compiler. But this is only half of the story. Even if T declares that T can give up its ownership, we are returning T. T declares that it can give up or relinquish its ownership to the rvalue. The function should be able to return the ownership. Now, auto means we will return a copy. Decltype auto means I can return anything, not only a copy of a value, but also the ownership of an object. In case of auto as return type, it always means we will return a copy of the value. So even if T declares to give up its ownership to the object, the function return type specification is auto. It is saying we will return a copy of an object. So if we build CLSC, the address is all different. It is returning a copy of T. This copy returned from the inner sum becomes new t. So the address changes all the time. A new copy is created. Now Decltype auto with this T is declaring that it is willing to give up its ownership. Then this Decltype auto transfers the ownership of the object. Now scroll down. Now in this function return, the ownership of T is transferred, relinquished. So this new ownership of T becomes T again. So the same ownership, the same object is accessed all the time. 63, 63C, 63C, 63C. Now scroll down here, Decltype auto, because sum can return ownership. Now X takes ownership of the return value of sum. We build again CLSC, the address of X, 65C, the address of T, 65C, 65C, 65C. So now X took the ownership of the value sum returns. Sum returns the ownership of T. So the address of X, this X, T, 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 all exactly the same thing. This is ownership transfer. To make this work, we have to typecast to the return value, and the function return type specification should be Decltype auto. As I said, Decltype auto is to recycle the original value auto. This R is X value. It is created only once. R is created only once. Then its value is copied to T. T is internal creation in the compiler. The copy is maintained to X. Please understand that I created this function sum to explain Decltype auto and the forwarding reference, also std move, std forward, this contract, why this typecasting is necessary. Also to explain the concept of ownership. In real application, you can simply implement type name arg types or sum of arg types args return. We use expression fold syntax. For example, we expand operator plus args or return args operator expand. We can code like this. Scroll down. Here, auto y sum of a, b, c, d, e, f, g, h, I, j, string y, and L. We build again CLSC. Y is 55. As I said, this function sum is to help my audience better understand what is Decltype auto.